to the practice problems video for the section on absolute value functions. Okay, here's question number 1. We're told to write an equation for each transformation, or this one transformation, of f of x is equal to absolute value of x. Okay, so let me just draw the normal absolute value of x, just as a reminder. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so our normal graph of absolute value of x looks something like this. Let me draw the lines here. Okay, where we have our vertex at the origin, 0, 0, and a slope of 1 and negative 1, respectively. So this is a slope of negative 1, this is a slope of 1. Okay, so that's what it looks like, and it's facing upward, right, pointing upward here. Okay, so now let's look at our graph that we're given here. So this point here, our vertex looks like it's actually at 3, 3, right? So our vertex is at 3, 3, which means that it moved to the right by 3. And it moved up by 3, right? Okay, so let's start writing what we think our equation looks like. So let me just write maybe, I don't know, let's call this g of x, okay? This is going to be equal to x and then something and then plus a 3, right? This one means up 3, so vertical shifting up 3. And then in order to go right 3, we have to say the opposite, so x minus 3. Okay, now let's see if there's anything else we have to add in front. So we do obviously see that this v is pointing down, right, instead of up. So that means we have to have some kind of vertical reflection, right? So if it's flipped upside down, that means we have to add a negative sign in front, okay? And the very last thing is to check to make sure that, let's see if we have any vertical or horizontal stretching going on. And we see that, well, from our vertex, if we go over 1 to the left, then in order to get to our graph, we have to go 1, 2, 3 units down, right? So that means we have a slope of, in this case, it's positive 3, so we have a slope of 3 and negative 3 respectively. So we can see that in comparing these slopes to what our normal slopes are, 1 and negative 1, we see that we have a vertical stretching of 3. So that just means we have to add a coefficient there of 3. So see, lots of 3's in our equation, and that's it, okay? That's the equation which describes the graph we were given in this problem. Okay, problem number 2, we're going to kind of do the opposite, and we're given a function, and we're told to graph it, sketch a graph of it. There we go. Okay, so the first thing is, what I like to do is to find a vertex first. So let's find our vertex. So normally what we have is some kind of x minus h, and then plus k, where h comma k is our vertex. Okay, so in this one we have x minus, kind of like a minus 3 inside there, alright, and then plus 1. So our h is negative 3, so that means negative 3, comma 1. So this one is our new vertex, okay? So let's start graphing this guy. So we have this kind of graph, so x and y, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so our vertex is at negative 3, comma 1, so right here, okay? We don't see any negative signs in front of the x or anywhere in front of the x, so that means we're going to have an upward pointing v, which is good. Okay, we sorted that out, and the last thing is to see, okay, we know that there's a positive 2 in front, right? So that means we have a vertical stretching by a factor of 2, which means instead of going over to the right and up 1, what we're going to do is go over 1 to the right and up 2, okay? So it'll look like this, and then if we do it one more time, we can go 1 over to the right and up 2. Okay, so the right side of our graph looks like this, and we're going to just do the exact opposite. It's going to be symmetrical on the left side, so we're going to go over 1 to the left and up 2, okay, over 1 to the left and up 2. Alrighty, so something like this, and that's going to be our graph here, okay? Ignore this little, like, tiny arrow at the bottom. That's kind of, like, not there for any reason, okay? Okay, for number 3, we're going to practice solving an absolute value equation. So for here, what we have to do is, because we don't have an inequality, this is an equation, so we're just going to form 2 mini equations, alright? So the first equation is going to be formed by simply just removing the absolute value signs, okay? And then the second equation is going to be formed by taking away the absolute value signs and setting that equal to the negative, or the opposite, of whatever we had before, okay? And now we're just going to solve these two separately. So we have 5x is equal to 13. So x is equal to a 13 over 5. That's positive. Or we have that 5x is equal to, let's see, a negative 11 plus 2 is a negative 9. So then x is equal to negative 9 over 5. Okay? So that's going to be our solution. We could just stick an or in between, and there it is.
We try.